Okay, so the idea now is to talk about the Kaufman criteria for deadlock conditions in operating system. We have four criteria. They are necessary. I mean, in order for a deadlock to occur, I must have all the four criteria, but they are not sufficient. Namely, if they all occur, it doesn't mean that it must be a deadlock, but I must have all of them um, to have a deadlock. So the idea of deadlock is that the situation of the system is that different processes need something from different process such that the system cannot move on. If I have two processes, one need something from the other and the other need something from the first one, and both cannot continue, so the system is stuck and cannot continue, this is a deadlock. Now, what are the four criteria, the Kaufman criteria, for a deadlock to occur in operating system? So the first one is the mutual exclusion, meaning that at least one resource must be non-shareable. Only one process can use it at a time. I mean, if I have a resource and I give it to a process, I cannot use this resource to another process as well. Mutual exclusion, the resource can be used only by one process at a time. And only after the process release this resource, only then different process can take and use this resource. This is the mutual exclusion, the first criteria. Now the second criteria is the hold and wait, namely that processes hold resources already allocated while waiting to acquire additional ones. Namely that the process can take a resource, take it to himself, and still wait to acquire new resources. So it's not that just one process, one resource a process can have. A process can take a resource and wait to another process. Now the next one is the no preemption. Namely, I cannot take out a resource from a process forcefully. Resources cannot be forcibly taken, they must be released voluntarily. I mean, if a process has a resource, I cannot just take out the resource if I need it for another process. I need that resource, that process with that resource will voluntarily release this resource in order to use this resource in another process. I cannot forcefully take it out from outside of the process. And the last criteria is the circular weight. I mean, one process depends on the next process. I have a circle. I have P1, then P2, then P3, and then again P1. And each of them wait for a resource held by the next. P1 waits, or let's say that P1 waits for a resource from P2, and P2 waits for a resource from P3, and P3 waits for a resource from P1. There is a circle over here that one depends on the other, and each one depends on the previous one, on the previous process. So there is a circle of dependencies that may be stuck because of it. So those are the four criteria, the Kaufman criteria for deadlock conditions, which are necessary but not sufficient. The mutual exclusion, the resource is not shareable. The resource can only be in one process. At least one resource behave like this. Hold and wait, can hold a resource and wait with him. No preemption, I cannot take out forcefully a resource from a process, and there is a circle of dependencies between the processes because one process depends on a resource in the previous process. Those are the four criteria of the deadlock conditions in operating systems, also known as the Kaufman criteria. Thank you very much. And if there are any mistakes or corrections, please tell me, and that's it.